Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 20 Cylinder, Cone and Sphere. We'll be discussing questions from Exercise 20 F and Exercise 20 G. Already we have discussed the main important concepts of this chapter and solved questions up to Exercise 20 E. Hope all the formulas are ready with you. Let's solve together questions from Exercise 20 F and 20 G. Let us start with a few examples from your revision paper which is at the back of your Selina publication textbook. Here is our first example. 16 glass spheres, each of radius 2 cm, are packed into a rectangular box of internal dimension 16 cm into 8 cm into 8 cm. And then the box is completely filled with water. Find the volume of water filled in the box. Here we have a box, a rectangular box, which means a cuboid. Okay. This is a rectangular box whose dimensions are given 16, 8, 8. Okay. Then this rectangular box is filled with 16 glass spheres, each of radius 2 cm. Within this box we have 16 glass spheres. Okay, 16 glass spheres are filled within this box, each of radius 2 cm. Okay, the remaining portion is filled with water. What we need to find is the volume of water filled in the box. Okay, here within the box we have 16 spheres, each of radius 2 cm and the remaining portion is filled with water. Then how to find the volume of water? We need to subtract the volume occupied by these 16 spheres from the total volume of the box. Yes, because this spheres fills a portion of the box. Now, we can write volume of box is equal to volume of 16 spheres plus volume of water filled. Okay. We need to find the volume of water filled. We'll be having volume of water filled is equal to volume of box minus volume of 16 spheres. Okay, separately we need to find the volume of box and volume of 16 spheres. What is the volume of box? The box is in the shape of a cuboid. For a cuboid, we know volume is equal to length into breadth into height. Here we have L into B into H is equal to 16 cm into 8 cm into 8 cm. Then we need the volume of 16 spheres. Volume of sphere is equal to 4 by 3 pi r cube. Here radius is 2 cm. Therefore, 4 by 3 pi 2 cube. We have 16 such spheres. Therefore, volume of 16 spheres is equal to 16 into 4 by 3 pi r cube. 2 cube. Okay. Now we can substitute volume of water filled. Volume of water filled is equal to volume of box minus volume of 16 spheres. What is the volume of box? Volume of box we have 16 into 8 into 8 minus volume of 16 spheres, that is 16 into 4 by 3 pi r cube, that is 2 cube, which is 8. Okay, 16, 8, they are common. which can be taken out. 16 into 8. Here we have a 8 and here we have 4. So I am taking 4 out. Then the remaining here will be having 2. 4 into 2 is 8. We are taking 4 out. Minus. We have taken 16. We have taken 8. We have taken 4. We'll be having pi divided by 3. What is pi by 3? 16 into 8 into 4 into 2 minus 22 divided by 7 into 3. Pi value is 22 divided by 7. Here already we have a 3 in the denominator, which is equal to 16 into 8 into 4 into, taking LCM, 7 into 3 is 21. 21 will be the LCM. Denominator will be having 21. 21 into 2 is 42 minus 21. Here we have 21. Therefore, 22, which is equal to 16 into 8 into 4 into 42 minus 22 is 20 divided by 21. When you do the calculation, the final answer will be 487.6. Here we have found the volume of water filled. Then what is the unit? Unit for volume is centimeter cube. Centimeter cube. Therefore, the volume of water filled inside the box is equal to 487.6 centimeter cube. Clear? Second example, a solid is in the form of a right circular cylinder with a hemispherical shape at one end and a cone at the other end. Their common diameter is 4 cm and the height of the cylindrical and conical portions are 12 cm and 7 cm respectively. Find the volume of the solid. We need to find the volume of solid. Let's make a rough figure. We have a cylindrical portion, then a hemispherical portion at one end and a conical portion at the other end. Okay. So this is how the solid looks like. They have a common diameter. So this is the diameter of cylinder. Same is the diameter of hemisphere. Same is the diameter of cone. Okay. Given diameter is equal to 4 cm. If diameter is 4 cm, we know radius will be equal to 2 cm. So the radius is 2 cm. Here again radius 2 centimeters. What else is given? The height of cylindrical portion and the conical portions are given. Height of cylindrical portion. This portion is 12 centimeter. And that of the conical portion. Conical portion, the height is, this height is 7 centimeter. Okay, we need to find the volume of solid. Height of the hemisphere is not given. Do we have height in case of hemisphere? No, right? To find the volume of hemisphere, we don't need the height because here again the height will be the radius of the hemisphere. Okay. Now, what is the total volume of solid? Volume of solid will be equal to, here we have 3 solids included. First, we have a cylinder, then a hemisphere and a cone. Therefore, the total volume of solid will be equal to volume of cylinder plus volume of hemisphere plus volume of cone. Okay, let us separately take each of the shapes. What is the volume of cylinder? Formula to find volume of cylinder? Pi r square h. Here r is the radius and h is the height. Then, in this case, we will be having pi r square, which is 2 square into height. Height is 12. Okay. Then, volume of hemisphere. Volume of hemisphere will be equal to 2 by 3 pi r cube. Here again the radius is 2 centimeter. 2 by 3 pi 2 cube. Next, volume of cone. What is the volume of cone? 1 by 3 pi r square h, that is equal to 1 by 3 pi 2 square. Height is 7. Okay. Now putting the values, the total volume of solid will be equal to pi into 2 square into 12 plus 2 by 3 pi into 2 cube plus volume of cone. Volume of cone is 1 by 3 pi into 2 square into 7. Here pi into 2 square is common. Here we have pi and 2 square. We have 2 cube here, from which 2 square can be taken out. Then here again we have pi into 2 square. The remaining, from this part it is 12. From this part we will be having 2 into 2, 4 by 3 plus, from this part we have taken pi into 2 square, then it is 7 by 3. Okay. Now it is easy to calculate. Put the pi value. 22 divided by 7 into 2 square into 3 is common, taking 3 out. So 3 is the LCM. 12 into 3. 12 into 3, 36 plus 4 plus 7, which is equal to 22 divided by 7 into 2 square 4 into 47 divided by 3. When you calculate this, the final answer you will be getting 218.064 centimeter cube. So this is the volume of solid, the final volume of solid, which includes hemisphere, cylinder and a cone. Okay, clear? Third example, a cylindrical vessel of diameter 14 cm and height 42 cm is fixed symmetrically inside a similar vessel of radius 8 cm and height 42 cm. The total space between the two vessels is filled with glass wool for heat insulation. Find the volume of the glass wool required. We have a cylindrical vessel whose radius is given 8 centimeter. Okay. And the height is 42 centimeter. Within this, another cylinder is fixed whose diameter is given 14 centimeter. If diameter is 14 centimeter, radius will be equal to 7 centimeter. So here you have the second cylinder within this, whose radius is 7 centimeter. We need to find the volume of glass wool. Glass wool is filled within the region between these two cylinders. Okay. That is, this portion you will be having the glass wool filled. Let's find the volume. How to find the volume now? So this region which I have shaded, you will be getting that region when you subtract the smaller cylinder from the larger cylinder. Yes. So volume of glass wool will be equal to volume of cylinder with radius 8 centimeter minus volume of cylinder with radius 7 centimeter. Okay. What is the volume of cylinder with radius 8 centimeter? That is the bigger cylinder. Here, let us take capital R as the radius of bigger cylinder and small r as the radius of smaller cylinder. Volume of bigger cylinder is equal to pi capital R square h. H height is same for both the cylinders. Next, the volume of smaller cylinder will be equal to pi small r square h. Then the required volume of glass wool will be equal to pi capital R square h minus pi small r square h. Okay, that is volume of glass wool is equal to pi into h into capital R square minus small r square. Now put the values. Pi 22 divided by 7 into height. Height is 42 centimeter. 42 into capital R square. Capital R square is 8 square minus small r square 7 square. Here 7 into 6 is 42. 22 into 6 into 64 minus 7 square is 49. That is 22 into 6 into 64 minus 49 will be getting 15. Okay, 15 into 6 is 90. 90 into 22 you will be getting 1980 centimeter cube. So this is the final answer. The volume of glass wool that is required for insulation will be equal to 1980 centimeter cube. Clear? So first make a rough figure and understand what we need to find. Accordingly, we can solve the question. Okay, let us take questions from exercise 20F. Here we have the first question of exercise 20F. From a solid right circular cylinder with height 10 cm and radius of base 6 cm, a right circular cone of the same height and same base is removed. Find the volume of the remaining solid. Let's make a rough figure. We have a right circular cylinder. So this is a right circular cylinder. From this right circular cylinder, we are removing a conical portion such that the height of the cone is same as the height of cylinder. Also, the base is same. Okay, with the same base is removed. So, height will be up to here. Starting from here, this is the required cone which is removed. We have the same base and height. Given that the height is 10 centimeter, height is 10 centimeter and the base is 6 centimeter. Radius of base 6 centimeter. Okay, we need to find the volume of the remaining solid. From the cylinder, this portion is removed. Remaining solid, that is this shaded region, gives us the remaining solid volume. Okay, therefore, we will be having volume of remaining solid equal to volume of cylinder minus volume of cone. Okay. Now what is the volume of cylinder? Volume of cylinder. What is the formula to find volume of cylinder? Pi r square h. Pi r square h. That is pi into r square 6 square into height is 10. Okay. Then volume of cone is equal to 1 by 3 pi r square h. Since in both these cases we have the same radius and height, you can either put the values and solve or directly take the formula and solve from it. I'll show you. This will be equal to pi by 3 into 6 square into 10. Okay. Now the volume of remaining solid. Volume of remaining solid will be equal to, take the formula, pi r square h minus 1 by 3 pi r square h. Pi r square h is common. Taking out pi r square h, will be having 1 minus 1 by 3. 1 from this part and 1 by 3 from this part. Pi r square h into LCM 3. 3 minus 1. Okay, that is 2 by 3 pi r square h. So, the volume of remaining solid is 2 by 3 pi r square h. Either you can do like this or find the values from here. That is the volume of cylinder separately, volume of cone separately, and subtract the volume of cone from the volume of cylinder. I think this will be easier. Therefore, the volume of remaining solid is equal to 2 by 3 into 22 divided by 7 into r square, 6 into 6, and height is 10 into 10. Okay, 3 and 6 can be cancelled. We get 2. 2 into 2, 44. 44 into 2, 88. 88 into 6 is 528. 528 into 10, 5280. 5280 divided by 7. Okay, when you solve this, you will be getting the answer. When you solve this, you will be getting the answer. The final answer is 754. 2 divided by 7. Put the unit centimeter cube. Okay, 754. 2 by 7 centimeter cube. Clear? Second problem, question 4 of exercise 20F. A circus tent is cylindrical to a height of 8 meters surmounted by a conical part. If total height of the tent is 13 meter and the diameter of its base is 24 meter, calculate total surface area of the tent. And the second, area of canvas required to make this tent, allowing 10% of the canvas used for folds and stitching. Okay. So here we have a tent which is made of a cylindrical portion and a conical portion. Circus tent is cylindrical to a height of 8 meter. So this height is 8 meter. Surmounted by a conical part. If total height of the tent is 13 meter. Total height is 13 meter. If total height is 13 meter and the cylinder's height is 8 meter, what is the height of the conical part? It will be equal to 13 minus 8, which is 5 meter. This height is 5 meter. Okay. Diameter of its base is 24 meter. Diameter is 24. Therefore, radius will be 12 meter. Here again, radius of conical part will also be equal to 12 meter. First, we'll calculate the total surface area of the tent. Okay. How to find the total surface area? Here, since this is a tent, the base of cylinder will not be included. Okay, it will be open. Also, the top will also not be included because from there you have the conical part. So, the curved surface area of cylinder plus curved surface area of the conical part will give us the total surface area of this tent. Okay. Total surface area of tent will be equal to curved surface area of cylinder plus curved surface area of cone. Okay, what is the curved surface area of cylinder? How to find curved surface area of cylinder? 2 pi RH plus, let us take the height of cone as some h dash, because we have taken h as the height of the cylinder. Then the curved surface area of cone will be equal to pi r L. Okay, pi r L. What is this L? L is the slant height. So we need to find the slant height first. Now this can be written as pi r into 2h plus L. Let us find the slant height. Slant height L is equal to, how to find slant height? We will be having using the Pythagoras theorem. Slant height square is equal to base square plus height square. Here the base is 12 meter and the height is 5 meter. And what will be the slant height? We have a Pythagorean triplet 5, 12. So we will be having L square equal to h square plus r square. Putting values, L square is equal to h square 5 square plus r square 12 square. L square is equal to 25 plus 12 square is 144. L square is equal to 169 and L is equal to 13. We have studied this Pythagorean triplet 5, 12, 13. Okay. So 13 is the slant height. Slant height is 13. 13 meters. Now putting the values to find the total surface area of tent. TSA equal to 22 divided by 7 into radius. Radius is 12 into 2h plus L. 2 into 8 plus L is equal to 13. That is 22 into 12 into 2 into 8 is 16. 16 plus 13, which is 29, divided by 7 will be equal to 254 into 29 divided by 7. When you do the calculation, you will be getting 1093.72 meter square. Here this is total surface area, so the unit will be meter square. Clear? Understood this much? Now the second part, we need to find the area of canvas required to make this tent, allowing 10% of the canvas used for folds and stitching. So when stitching comes, we need some area of the canvas, right? So here there will be some folds. Then here there will be some folds. Okay, for all these folds, we need canvas, right? So the total area of canvas required will be equal to total surface area of tent, okay, plus the area that is used for the folds and stitching, okay. Given that the area that is used, that is the canvas that is used for folds and stitching is 10% of the total area of canvas required, plus 10% of total area of canvas required. We need to find the total area of canvas required. Okay, we know the total surface area of tent, which is equal to 1093.71 meter square. Here we have the decimal. Let's convert it into fraction, right? 254 into 29 will be getting 7656 divided by 7. Okay, we'll take this. So this is the total surface area of tent. Here, total area of canvas required, total area minus 10% of total area will be equal to total surface area of tent, which is 7656 divided by 7. Okay. Now the total area minus 10% of total area. So taking total area outside, we'll be getting total area into 1 minus 10%. 10% can be written as 10 by 100. 10 by 100. 0, 0 gets cancelled. And that is equal to 7656 divided by 7. Okay. So the total area into 10 comes in the denominator. 10 minus 1, which is 9. Okay. Total area into 9 by 10 is equal to 7656 divided by 7. Therefore, the total area is equal to 7656 divided by 7 into 10 divided by 9. That is taking the reciprocal for calculation. When it is taken from the left hand side to right hand side, you need to take the reciprocal of this. So what is the final answer? When you do the calculation, you will be getting 1215.23 meter square. Okay, so this is the total area of canvas required. Okay, the total area of canvas required is equal to 1215.23 meter square. Understood this problem? Okay, so remember, the area of canvas required is not just the total surface area of tent. There includes the area that goes for stitching and folds. You will have to add that as well and then find the total area of canvas required. Okay. Problem 3. Question 6 of exercise 20F. A vessel is a hollow cylinder fitted with a hemispherical bottom of the same base. The depth of the cylindrical part is 4 2/3 meter and the diameter of the hemisphere is 3.5 meter. Calculate the capacity of the internal surface area of the vessel. Okay, we need to find the capacity, which means the volume and the internal surface area of the vessel. Okay, here we have a cylinder whose base is a hemisphere. Okay, this is how it looks. Given the depth is 4 2/3 meters. 4 2/3 meters will be equal to 4 3s are 12, 12 plus 2 14, 14/3 meter. So 14/3 meter is this depth. Okay, then what is given? The diameter of hemisphere is 3.5 meter. 3.5 meter can be written as 7/2 meter. 3.5 meter is 7/2 meter. Now 7/2 meter is the diameter. We need radius. Then what will be the radius? Radius will be equal to 7/2 divided by 2 and that is 7/4 meter. Okay, 7/4 meter is the radius. Now this 7/4 meter will be the radius of the hemispherical portion and the cylindrical portion. First, we'll find the capacity, which means the volume. Volume of vessel is equal to volume of cylinder plus volume of hemisphere. Okay, what is the volume of cylinder? Pi r square h. Pi r square h plus volume of hemisphere is 2/3 pi r cube. You can take pi r square outside. Then we have h plus 2/3 r. Okay, here the radius of the cylinder and radius of hemisphere are the same. Now put the values. Pi 22 divided by 7 into r square is 7/4 into 7/4. Then the height is 14/3 plus 2/3 into 7 divided by 4. Okay, that is equal to 22 divided by 7 into 7/4 into 7/4 into 14/3 plus 14/3 into 4. Okay, again a 14/3 can be taken out. Then we'll be having 22 divided by 7 into 7/4 into 7/4 into 14/3 into 1 plus 1/4. That is equal to 22 by 7 into 7/4 into 7/4 into 14/3 into 4 plus 1, 5. 5 divided by 4. When you do this calculation by cancelling, you will be getting the final answer 56.15 and the unit is meter. Therefore, volume will be meter cube. So, this is the final answer 56.15 meter cube. So, I didn't do the calculation. You can calculate, you can cancel the 7, 4, etc. and find the answer. You will be getting 56.15 meter cube. Next, we need to find the internal surface area of the vessel. Internal surface area includes the curved surface area of hemisphere and the curved surface area of the cylinder. Okay, internal surface area will be equal to, here curved surface area of cylinder is 2 pi r h plus curved surface area of the hemisphere will be equal to 2 pi r square. We can take 2 pi r remaining h plus r. that is equal to 2 into 22 by 7 into 7 divided by 4 into H plus R. H is 14 by 3 plus 7 by 4. Okay. When you calculate this, you will be getting final answer 70.58 and the unit is meter square. Here it is the internal surface area, therefore the meter square will be the unit. Okay, 70.58 meter square. Understood this? Problem number 4, question 7 of exercise 20 F. A wooden toy is in the shape of a cone mounted on a cylinder as shown alongside. If the height of cone is 24 centimeter, the total height of toy is 60 centimeter and the radius of the base of cone is equal to twice the radius of the base of cylinder and that is 10 centimeter. Find the total surface area of toy given that the pi value should be taken 3.14. Somewhat this is how the toy looks like. Here we have a cylinder and a cone on the top of cylinder. Let us take capital R as the radius of base of cone and small r as the radius of base of cylinder. Okay. Let R be radius of base of cone and small r radius of base of cylinder. Okay. We'll take capital H as the height of cone and small h the height of cylinder. Okay. Here we need to find the total surface area. To find the total surface area, when you look at this figure, to get the total surface area, we have a base. Base of cylinder should be included. Then, curved surface area of cylinder should be included. Curved surface area of cone should be included. One more region, that is the region which I am shading now. That is the base of the cone excluding the top of cylinder. Okay, base of cone excluding the top of cylinder. So, these four when added will be getting the total surface area of this toy. Here we can write total surface area of toy will be equal to curved surface area of cone plus curved surface area of cylinder plus area of base of cylinder plus area of base of cone minus area of top of cylinder. Okay. Now, what are the given values? Given that the height of the cone is 24 centimeter. This height is 24 centimeter. Also given that the total height of toy is 60 centimeter. If total height is 60 centimeter and 24 centimeter is the height of cone, then the remaining will be the height of cylinder, which is 36 centimeter. You will be getting the height of cylinder 36 centimeter. 36 plus 24 is equal to 60 centimeter, which is the total height of toy. What else is given? Given that the radius of base of cone is equal to 10 centimeter. Yes, capital R is equal to 10 centimeter and twice the radius of the base of cylinder is 10 centimeter. 2 into base of cylinder is R. Radius of base of cylinder is R. 2 into R is 10 centimeter, which means R will be equal to 10 divided by 2 and that is 5 centimeter. Here we have base 10 centimeter. This base of cylinder is 5 centimeter. Okay. In order to find the curved surface area of cone, what is the formula? Pi r L, where L is the slant height. We know the height. and the radius. So we can easily find what the slant height is. We'll be having L is equal to, here we have taken capital H as the height of cone and capital R as the radius of the cone. L square will be H square plus R square. L square will be equal to 24 square plus 10 square. What is 24 square? 576. Yes, 576 plus 100 is L square. L square is equal to 576 plus 100 is 676. Then L will be root of 676, which is 26 centimeter. Okay, we got the slant height 26 centimeters. Now we have total surface area of toy is equal to curved surface area of cone pi r L. Here we have taken capital R as the radius of base of the cone. Okay, curved surface area of cylinder 2 pi r h. Area of base of cylinder. What is the area of base of cylinder? Base is circular in shape, therefore pi r square plus pi r square. Then area of base of cone. Base of cone, again it is a circular in shape, therefore we will be getting pi capital R square minus area of top of cylinder. Top of cylinder. Here we have top of cylinder, that is again circular in shape, of radius small r. Therefore pi small r square plus pi r square and minus pi r square can be removed. We will be having pi r L plus 2 pi r h plus pi r square. Pi can be taken out. Capital R L plus 2 r h plus capital R square. Put the values here. Pi is 3.14 into capital R into L. Capital R is 10 into L is 26 plus 2RH. 2 into R is 5 into height is 36 plus R square. Here R is capital R, which is the radius of base of the cone, 10 square. That is equal to 3.14 into 26 into 10 is 260 plus 2 into 10, 2 into 5 is 10, 10 into 36 is 360, 10 square is 100. So on adding this, we will be getting 260 plus 360 plus 100, which is 720. 720 into 3.14. 3.14. So doing the calculation, you will be getting the final answer. When you do the calculation, you will be getting the final answer 2260.8 centimeter square. Okay, so this is the final answer. Clear? How to find the total surface area of the toy? You should know which are the areas that is included, which should be excluded. Okay, then we will be able to find the area. Okay, problem 5. Question 14 of exercise 20F. A cylindrical can whose base is horizontal and of radius 3.5 cm contains sufficient water so that when a sphere is placed in the can, the water just covers the sphere. Given that the sphere just fits into the can, calculate the first question. Total surface area of the can in contact with water when the sphere is in it. We know that when you take a can, okay, and fill it with water up to some point. Okay, when you add something, when some solid is added to it, like a stone or something like that, what happens? The water level keeps rising. Okay, here what is done? A sphere is put into this can such that the sphere will completely fit inside the can. Okay, the sphere will completely fit inside the cylindrical can. Then what happens? The water level will rise. Yes, the water level will also rise. It is given that the water level will be reaching at this point where the sphere's top end. Okay, we need to find the total surface area of the can in contact with water when the sphere is in it. Okay, that is up to here. Given the radius of the base of cylinder, which is 3.5 centimeter. This 3.5 centimeter will be the radius of sphere as well. Okay, let us find the total surface area. First question. Total surface area of can in contact with water will be equal to, here this portion is in contact with the water, this portion is in contact with the water, then base is in contact with the water and the curved surface is also in contact with water, which means the cylinder's curved surface plus the cylinder's base will be in contact with water when the sphere is put into it. We don't have to take the top because the top will be open. Okay, that's why we are taking only the base and the curved surface. That is equal to CSA of cylinder plus area of base. Put the values. CSA of cylinder, curved surface area of cylinder is 2 pi RH plus area of base is pi r square. Pi and r can be taken out. Before that, what is the height? Height, this is the height of cylinder, right? Here we know this part is the radius of sphere. Okay, here we will be getting the total height to be equal to diameter of sphere. That is, diameter will be 2 times radius, 2 into r. Therefore, we can write height will be equal to 2 into r. Height will be equal to 2 into r. So, 2 pi r into 2r. In place of height, I am giving 2r plus pi r square. Okay. So, we will be taking 4 pi r square plus pi r square, which will be equal to 5 pi r square. Okay. Now, put the value 5 into 22 divided by 7 into r square. Here radius is 3.5 centimeter. 3.5 into 3.5. In order to remove the decimal, what can be done? Or you can take like this, 3.5 into 2 is 7, right? So, 3.5 and 7 can be cancelled. You get 2 here. 2, 22, you get 11. 3.5 into 5 into 11. What is the final answer? You will be getting 192.5 and the unit is centimeter square. Okay, 192.5 centimeter square will be the final answer. That is the total surface area of can in contact with water when the sphere is put into the can. Okay, got this answer? Next, we need to find the depth of water in the can before the sphere was put into the can. Okay, we had a can, a cylindrical can. Let us take here up to a height of x. Water was present inside this cylindrical can. What happens when a sphere is added into it? When a sphere is put into it, the water level increases. We need to find the initial height of water which was present in the can. How to find? We can say that the total volume of cylinder will be equal to, here inside the cylinder we have a sphere and water. Okay, that will be the volume of water plus volume of sphere. Okay, what is the volume of water? Initially, before the sphere was put inside the can, there was only water, and the water will be in the shape of, it is taking the shape of cylinder up to a height of x. Radius will be the same. Okay, so to get the volume of water, we'll be considering the shape of the cylinder. Okay, volume of cylinder. What is the volume of cylinder? Pi r square h is the volume of cylinder. Next is volume of water. You have to take the initial case. When only water was present, the total volume will be equal to the volume of water up to a height of x. Okay, that will be pi r square into x. Okay, x is the height, therefore pi r square into x. Then volume of sphere. Volume of sphere will be 4 by 3 pi r cube. Okay, we have taken the height as h. Okay, and this h will be equal to 2 times the radius, because the height of the cylinder is equal to the diameter of the sphere. Since r is the radius of sphere and that is also equal to the radius of base of the cylinder, 2 times radius will give us diameter, and that diameter is equal to height. H is equal to 2r. Okay. Pi r square into 2r will be equal to pi r square into x plus 4 by 3 pi r cube. Okay. Here pi r square, pi r square can be cancelled. When r square is cancelled, r will be remaining here. We need to find x. What is x? X will be equal to, taking other terms to the opposite side and keeping x in one side, will be having 2r here minus 4 by 3 r. Okay, that is x will be equal to, r is common, taking r outside, 2 minus 4 divided by 3. X is equal to r into, taking LCM, 3 at the base, 3 into 2, 6 minus 4. X is equal to, what is r? R is equal to 3.5. 3.5 into 6 minus 4, 2 divided by 3. Okay, 3.5 into 2 is 7. 7 by 3, that is equal to 1 by 3 centimeter. We have taken x as the height up to which water was present initially. Okay, therefore the depth of water before sphere was put is equal to 1 by 3 centimeter. Is that clear? So when the sphere was put into it, the water level has risen from this x up to total height h. Okay, now let us solve problems from exercise 20G. Problem 6, question 1 of exercise 20G. What is the least number of solid metallic spheres, each of 6 cm diameter, that should be melted and recast to form a solid metal cone whose height is 45 cm and diameter 12 cm. So let us take number of spheres as some n into the volume of each small sphere will give us the volume of the cone. Okay. We don't know the number of spheres. A few spheres are taken and they are melted and recast into a cone. Given the diameter is 6 cm, diameter of sphere is 6 cm, which means the radius will be 3 cm. What about the cone? Height of cone is given, which is 45 cm. And the diameter is also given, which is 12 cm. Okay, diameter is 12 cm. Then what will be the radius? Radius will be equal to 6 cm. Okay, let number of spheres be n. Okay. Number of spheres into volume of one sphere will be equal to the volume of cone. What is the volume of sphere? Volume of sphere will be equal to 4 by 3 pi r cube. Here the radius is 3 centimeter. That is 4 by 3 pi 3 cube. Okay. Then what is the volume of cone? Volume of cone is equal to 1 by 3 pi r square h equal to 1 by 3 pi r square. Here the radius is 6 centimeter. Therefore 6 square into height is given 45. Okay. N into volume of one sphere, which is 4 by 3 pi 3 cube, will be equal to volume of cone, which is 1 by 3 pi 6 square into 45. Okay. Then what is n? N will be equal to 1 by 3 pi 6 square into 6 into 6 into 45 divided by 4 by 3 pi into 3 into 3 into 3. Okay. So this denominator 3's can be cancelled. Pi can be removed. 3 into 2 is 6. Again 3 into 2 is 6. Then 3 and 45 can be cancelled. You will be getting 15. Here we have a 4. Here we have 2 into 2, 4. 4 and this can be cancelled. So the value of n is 15. 15 spheres. Okay. 15 spheres are taken. They are melted. Each of 3 centimeter to form a cone which is of height 45 centimeter and radius 6 centimeter. Okay. Problem 7. Question 5 of exercise 20G. The diameter of a sphere is 6 centimeter. It is melted and drawn into a wire of diameter 0.2 centimeter. Find the length of wire. Okay. Wire. What is the shape of a wire? Is it a sphere, cone, cylinder, which can be taken? It is a cylinder, right? With a very less diameter. So a wire is a cylinder with a very small diameter. Here we have a sphere which is converted into a thin wire. Okay. So wire is a cylinder. Remember this point. Given the diameter of sphere is 6 centimeter. If diameter is 6 centimeter, what is the radius? Radius will be 3 centimeter. Radius 3 centimeter. Okay. Into a wire of diameter 0.2 centimeter. If diameter is 0.2 centimeter, then radius will be equal to 0.1 centimeter. Here the radius is 0.1 centimeter. We need to find the length of wire. Okay. We have volume of sphere is equal to 4 by 3 pi r cube, which is 4 by 3 pi. Here what is the radius? Radius of sphere is 3 centimeter. 3 cube. Okay. Next we need the volume of wire, which is volume of cylinder. Volume of wire will be equal to pi r square h. What is h in this case? H is the length of wire. Let h be the length of wire. Okay. Then the volume of wire will be equal to pi into r square. Here we have 0.1 centimeter, which can be written as 1 by 10 centimeter. Okay. 1 by 10 square into the length of wire, which is h. We'll be having volume of sphere is equal to volume of wire. Why? Because from the sphere, this wire is made by melting. Volume of sphere is equal to volume of wire. Volume of sphere, that is 4 by 3 pi 3 cube will be equal to volume of wire pi into 1 by 10 square h, or pi into 1 by 10 square h is equal to 4 by 3 pi 3 cube. Now this can be written as, we need h. We need to find what h is. Taking all other terms to the opposite side, or you can directly cancel pi from both the sides. H will be equal to 4 into 3 into 3 into 3 divided by 3. Then 10 square. Here we have 10 square. 10 is in the denominator. When it goes to opposite side, it goes to the numerator. And it is 10 square. Therefore, 10 into 10. 3 gets cancelled. 4 into 3, 12. 12 into 3, 36. 36 into 10, 360. 360 into 10, 3600. So, the length of wire is 3600 centimeter. Okay. So, here from a metal bowl of 3 centimeter diameter, we are making a wire of very small radius, which is 0.1 centimeter, and the length is 3600 centimeter. Okay, so it is a very thin wire. 3600 centimeter can be written as 36 meter. 36 meter long wire is made. Okay, length of wire is equal to 36 meters. Clear? Problem number 8, question 10 of exercise 20G. A cylindrical water tank of diameter 2.8 meter and height 4.2 meter is being fed by a pipe of diameter 7 centimeter through which water flows at a rate of 4 meter per second. Calculate in minutes the time it takes to fill the tank. Here we have a cylindrical tank. This cylindrical tank is being filled with a pipe. Pipe is cylindrical in shape. Okay. So, water starts flowing from here and it reaches till here. After which the water is fed into this water tank. Okay. So, the volume of water in this pipe will be equal to the volume of water in this entire cylindrical tank. So, given that a cylindrical water tank of diameter 2.8 meter, which means radius will be half of diameter. 2.8 meter is the diameter, therefore radius will be 1.4 meter. 1.4 meter, and height is given, which is 4.2 meters. Okay. Then the diameter of the pipe is given, which is 7 centimeter. Either we have to take all the quantities in centimeter, or we have to convert and take in meter. So, meter is a more comfortable unit. So, 7 centimeter will be equal to 7 by 100 meters. Yes, we know 1 meter is 100 centimeter. Therefore, 7 centimeter will be equal to 7 by 100 meter. Now, 7 by 100 meters is the diameter. We need radius. What will be the radius then? 7 by 2 centimeter, which is 7 by 2 into 100 meters. Okay, 7 by 2 into 100 meters is the radius of the pipe. 7 by 2 into 100 meters. Okay. We need to calculate in minutes the time it takes. Okay, how to calculate the time? Here, the water flows at a rate of, the speed is given, which is 4 meter per second. Yes? Okay, we have studied distance is equal to speed into time. Yes? So, the water travels a distance through the pipe from here to here. So, this is the total distance it travels. Total distance travelled by the water is the height or the length of the pipe. Yes, water starts from here and ends here within the pipe, which is the total distance travelled within the pipe is equal to height of the cylindrical pipe or the length of the pipe. Okay. Now, how to calculate this distance? We have distance is equal to speed into time. So, we can write height is equal to speed into time. Here, speed is given, which is 4 meter per second. And the time is what we need to calculate. When you calculate, you will be getting time in units of minutes, after which we can convert it into seconds. Okay, so remember this, distance is equal to speed into time. We need to calculate the time. Okay, we have h, the height of the cylindrical pipe, as the distance travelled by the water. We'll be having volume of cylindrical tank is equal to volume of water in pipe. So, pipe is again cylindrical in shape. What is the volume of cylindrical tank? That is equal to pi r square h. Yes, let us take capital R as the radius of base of cylinder and capital H as the height of cylinder. Okay. Capital R square into H is equal to volume of water in pipe can be calculated. Here we have taken small h as the height and small r, let small r be the radius of base of the pipe. Okay. Therefore, pi small r square into h. Yes. Now, what is h? H is equal to speed into time. We need to find time. So, in place of h, we can substitute 4 into t. Okay. Pi gets cancelled. Capital R square. What is the value of capital R? 1.4. 1.4 into 1.4 and height is 4.2 meters into 4.2 is equal to R square, small r square, that is 7 divided by 2 into 100 whole square. 7 divided by 2 into 100 into 7 by 2 into 100 into h. In place of h, we will be putting 4 into t. Okay. So, here we are not reducing the 7 divided by 200 because the cancelling and the calculation will become easier. Now, this t is kept in one side. Opposite side we have 1.4 into 1.4 into 4.2. This denominator part goes to the numerator, that is 2 into 100 into 2 into 100 whole divided by numerator goes to the denominator, that is 7 into 7 into 4. Okay, t is equal to 1.4 into 1.4 into 4.2 into 2 into 100 into 2 into 100 divided by 7 into 7 into 4. Now, using this hundreds, we can remove the decimals. We have 4 decimal places. We have 3 decimal places to remove, and after that a 10 will be remaining. So, t will be equal to 14 into 14 into 42 into 10 into 2 into 2. Okay. Here we have 4 zeros which helps to remove 3 decimals, and the remaining 10 I have multiplied here. Denominator 7 into 7 into 4. Okay. 7, 14, 2 times. Again 7, 14, 2 times. 2 into 2 is 4. Even that can be cancelled. Then we will be having t is equal to 42 into 2 into 2, 4 into 10. And t is equal to 42 into 4 will be 168. 168 into 10, 1680. So, t is equal to 1680 seconds. Remember this. T is equal to 1680 seconds. We need in minutes. Okay. We have 1 minute is equal to 60 seconds, or we can write 1 second is equal to 1 by 60 minutes. Okay, 1 second will be equal to 1 by 60 minutes. If 1 second is 1 by 60 minutes, what about 1680 seconds? 1680 seconds will be equal to 1 by 60 into 1680 minutes. Okay, if 1 second is equal to 1 by 60 minutes, what is 2 seconds? 2 seconds will be 2 into 1 by 60 minutes. Here we have 1680 seconds and that will be equal to 1680 into 1 by 60. 0, 0 gets cancelled. 6 and 168. When reduced, you will be getting 28 minutes. Okay, so the required time, the time water takes to flow from here to here is equal to 28 minutes. You have to convert, you cannot keep it in seconds. Remember, the speed is given in meter per second. Okay, therefore we are getting time in seconds. Once you get time in seconds, you have to convert it into minutes. Don't keep it in seconds only. Okay, let's move on to the next problem. Problem 9, question 11 of exercise 20G. Water flows at 9 km per hour through a cylindrical pipe of cross-sectional area 25 cm square. If this water is collected into a rectangular cistern of dimension 7.5 meter by 5 meter by 4 meter, calculate the rise in the level of cistern in 1 hour 15 minutes. Okay, similar to a problem that we have solved just before. Here we have a rectangular cistern. In the previous question it was a cylindrical tank. Now we have a rectangular cistern into which water is filled through a pipe. Okay, cross-sectional area of the pipe is given, which is 25 cm square. Cross-sectional area of pipe is equal to 25 cm square. Okay, we know that 1 meter is equal to 100 centimeter and 1 centimeter will be 1 by 100 meters. Okay, here we have 25 centimeter square which we need to convert it into meter square. 1 centimeter is 1 by 100 meter, which means 1 centimeter square will be 1 by 100 into 1 by 100 meter, which is 1 by 10,000 meter square. Okay, here we have 25 centimeter square and that will be equal to 25 divided by 10,000 meter square. Okay, so this is the cross-sectional area of the pipe. This cross-sectional area is equal to 25 divided by 10,000 meter square. What else is given? Water flows at 9 km per hour through the cylindrical pipe. So, through this pipe of some height, we don't know what the length of the pipe is. Okay, the water flows at a rate, the speed is given 9 km per hour, which means in 1 hour, the water flows through a distance of 9 km. That is what 9 km per hour means. In 1 hour, 9 km is the distance travelled through the pipe by the water. Okay, here we need to calculate in 1 hour 15 minutes. In 1 hour 15 minutes. 1 hour 15 minutes. 1 hour 15 minutes will be equal to 1 hour plus 15 minutes when converted into hours will be getting 15 divided by 60 hour. Yes, 15 by 60 is 1 by 4. 1 hour plus 1 by 4 hour will be equal to, on adding we get 5 by 4 hours. Okay, so we need to find in 5 by 4 hours what is the distance. What will be the distance in 1 hour if it is 9 km? In 5 by 4 hours it will be 5 by 4 into 9 km. So you can write distance travelled by water through cylindrical pipe in 1 hour 15 minutes will be equal to 5 by 4 into 5 by 4 is the time, because in 1 hour it is 9 kilometers. Therefore, in 5 by 4 hours it will be 5 by 4 into 9 kilometers. We need everything in meters. To convert kilometers to meters, we need to multiply with 1000. Okay, that will be equal to 5 by 4 into 9 into 1000 meter. So, this is the distance the water travels from here to here, which means it will be equal to the height of cylindrical pipe or the length of the pipe. Okay. Now, we got the length of pipe, which is equal to 5 by 4 into 9 into 1000 meter. The volume of water in the pipe will be equal to the volume of water that is filled in this cistern, rectangular cistern, in a time 1 hour 15 minutes. Okay, it is not completely filled, but we have to find what is the raise of water in this cistern. Okay, given the dimensions of the cistern, that is 7.5 meter will be the length, 5 meter will be breadth and 4 meter will be the height. We need to find the height. Yes, so we don't need to take this 4 meter. 4 meter is the total height. We need the length and breadth, which is the area of the base of the rectangular cistern. And we have to find what the height, what the raise in height is. Let us take it as some x. Okay, up to x the water gets filled in 1 hour 15 minutes. Okay, then what is the volume? In this case, the volume will be equal to 7.5 into 5 into x. This is the volume. Yes, so this is a cuboidal shape. In cuboid, we have length into breadth into height as the volume. So here the length is 7.5, breadth is 5 and height we have taken as x. X is the raise of water. That will be equal to the volume of this cylindrical pipe. What is the volume of cylindrical pipe? For a cylinder, it is pi r square h. Pi r square is the cross-sectional area and the cross-sectional area is given, which is 25 centimeter square, 25 by 10,000 meter square. Okay, 25 by 10,000 pi r square. Then we have a h. What is h? h is the length of pipe or the height of the cylinder, which we have calculated. So, this distance is the distance travelled by water through the pipe. Okay, which is 5 by 4 into 9 into 1000. Okay, when you solve this, you will be getting the x value. 1000, 10,000 can be cancelled. You will be getting 10 here. 5 and 5 can be cancelled. 10 into 7.5 is 75. 75x is equal to 25 into 9 divided by 4. And x will be equal to 25 into 9 divided by 75 into 4. Okay. 25 and 75 can be cancelled. We get 3 here. 3 and 9 can be cancelled. Again we get 3 here. So it is 3 by 4. What is the unit? 3 by 4 meters. 3 by 4 is 0.75 meters. If you need it in centimeters, you can multiply with 100. Then we get 75 centimeters. 75 centimeter is the rise in level of water in the system. Okay. Understood how we have determined? So, be careful with the units. Never use different units. If you are using meter, use only meters, not centimeters or kilometers. Okay. Clear? Next, problem 10, question 20 of exercise 20G. A conical tent is to accommodate 77 persons. Each person must have 16 meter cube of air to breathe. Given the radius of the tent as 7 meter, find the height of the tent and also its curved surface area. Here you have a conical tent in which 77 persons are accommodated. Given each person should have 16 meter cube of volume of air to breathe. Okay. So we will be having 77 into volume of air required for each person equal to the total volume of conical tent. Okay, 77 is the number of persons into the volume of air required for each person will be equal to the total volume of conical tent. We need to find the height of the tent given that the radius of tent is 7 meter. Okay. Volume of air required for each person we know that is given 16 meter cube. 77 into 16 will be equal to the total volume of conical tent. How to find volume of cone? Volume of cone is 1 by 3 pi r square h. We need the h value. 1 by 3 pi r square h is equal to 77 into 16. Okay. Then put the values 1 by 3 into 22 by 7, radius is 7, 7 into 7 into height is equal to 77 into 16. Okay, here 7 and 7 can be cancelled, keeping height in the left hand side, taking all other terms to the right hand side. 77 into 16, denominator we have a 3, 3 is taken to the numerator. Numerator we have 22 and 7 taken to the denominator. 22 into 7. 7, 77 we get 11 here. 11, 22 we get 2 here. 2 into 6, 2 into 8 is 16. So 8 into 3 gives us a height. Okay. Height h is equal to 24. 8 into 3, 24. Meters. Check the unit. Here the unit is meter. 24 meter is the height of cone. Next, the second part of the question, we need to find the curved surface area. How to find curved surface area of cone? Curved surface area is equal to pi r L. What is L? L is the slant height. Here we know the radius and also the height of the cone. Okay. Then we'll be having slant height. L square is equal to h square plus r square. L square will be 24 square plus 7 square. What is 24 square? 24 into 24. 16, 9, 8, 4. That is 576. So 576, L square is equal to 576 plus 49. L square is equal to 625. Then L will be root of 625, which we all know, 25. Now remember, this is again a Pythagorean triplet, 7, 24, 25. When you find 7 and 24, you should be able to write 25. There are many other Pythagorean triplets, 3, 4 and 5. These are Pythagorean triplet. 3 square plus 4 square will be giving you 5 square. Then you will be having 5, 12, 13. This is a Pythagorean triplet. Similar to this, here 7, 24 and 25 is a Pythagorean triplet. We have got the slant height value, which is 25 meters. Put to find curved surface area, 22 divided by 7 into 7 into 25. Okay, 7 gets cancelled. 25 into 22, which is equal to 550. What is the unit? Here All the measures are given in meters. Therefore, the unit should be meter square. Curved surface area unit is meter square. Okay, that's all for today. In today's class, we have solved problems from exercise 20F and 20G. There are more problems which you can solve on your own. I'll be back with a new chapter in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.